Hello and welcome. What if I told you that the rules that govern an atom of oxygen and a line of computer code are, well, surprisingly similar? Today, we're going deep, decoding the fundamental blueprints that connect our physical and digital worlds, everything from the air we breathe to the apps on our phones. I know, it sounds like a weird question, right? But the answer, it actually gets at a really fundamental human drive. Our endless quest to decode the blueprints of our universe, whether they're written in the language of elements or in algorithms.
Because really, everything has a blueprint. There's a fundamental language that dictates how it all works. From the elements that literally make up our world to the software running our computers, there are rules and structures just waiting for us to understand them. And if you can read the blueprint, you can understand the system.
So, let's start with the ultimate blueprint for all physical matter, the periodic table of elements. You can really think of it as the master key to all of chemistry.
I mean, this remarkable chart organizes all 118 known elements. And it doesn't just list them, no. It arranges them in a way that lets us understand their properties and even predict how they're going to behave. It's pretty amazing.
And to read this blueprint, you just need to know the language. Each little box gives you the element's symbol, its full name, and maybe the most crucial piece of information, the atomic number. That one number tells you exactly how many protons are in a single atom of that element.
And get this simple, universal language is just so powerful. As one reader shared, even 55 years after his last chemistry class, this blueprint allowed him to help his granddaughter with her homework. It's a truly timeless skill. But the real genius here is in the table structure. See, elements in the same vertical column or group, they all have the same number of valence electrons. Those are the outermost ones. And that's what makes them react in very similar ways. They're kind of like chemical family members. And it's not just the columns. The horizontal rows, or periods, they matter too. Elements in the same row all share other important structural traits. They have the same number of electron shells, which influences things like their size and their energy levels. Okay, so to see this blueprint in action, let's really zoom in on one absolutely crucial element, oxygen. It's number 8 on the chart, and, well, it's pretty essential for all of us. We all know oxygen as the air we breathe, right? But some folks argue it's actually a nutrient. I mean, think about it. A nutrient is just a substance that nourishes life and fuels growth. And by that definition, oxygen is hands down one of the most critical nutrients we have.
And its role goes way beyond just breathing. Our deep understanding of oxygen's blueprint allows us to harness its properties for literally everything, from powering our cells to cutting right through steel with a torch. Its discovery even helped kill off old, bogus scientific theories and completely redefine chemistry itself.
And this is where reading the blueprint becomes a matter of life and death. Seriously, in medicine, a precise understanding of oxygen isn't just important, it is everything. So, for most patients, doctors are going to aim for an oxygen saturation level of 92 to 96%. That's the target.
But, and this is so critical, for someone with a condition like COPD, that blueprint changes. The target shifts down to a very narrow 88 to 92%. It seems like a tiny difference in the numbers, right? But it's a difference that has a massive, massive impact on the outcome.
So, this human drive, this need to decode and master the building blocks of our world, well, now it's being applied to entirely new blueprints, the ones that are going to shape our future. Just take hydrogen, element number 1. By understanding its blueprint, we used it to power space shuttles. And now, we're using that very same blueprint to build a cleaner energy future, creating fuel cells that produce electricity with nothing but water as a byproduct. How cool is that? And this shift from using elements to build things physically to using logic to build things digitally, well, that brings us right back to our original question. What does any of this have to do with a line of code? The parallel here is just fascinating. Think about it. A chemist uses rules like valency to predict how elements are going to react. A software developer, they use their own set of rules, like writing unit tests to make sure each piece of code works perfectly, or error handling to plan for what happens when things go wrong. In both cases, you're not just mixing things together, you are architecting a stable system based on fundamental principles. Just like an AI coding assistant told a developer named Jerry, the modern goal isn't just to write code anymore. It's to architect intelligent systems. It's all about understanding the blueprint, not just laying the bricks.
So you see, the skill of decoding blueprints is universal. It applies to the periodic table just as much as it applies to system architecture. Which kind of leaves us with one final thought. Now that we're getting so good at mastering the blueprints of matter and machines, what complex system will humanity decide to decipher next?